Well, I can sort of in order of, I'd say where we're having the most impact already. I think vaccines is up there. There'll be, as I mentioned, my colleague Neil King here has the Institute for Protein Design has a coronavirus vaccine that's in late phase 3 trials that looks much more potent than the mRNA vaccines that should hopefully be out next year. We have COVID therapeutics on the way to the clinic, cancer therapeutics. And so I think vaccines and therapeutics are high up on the list of areas where protein design will make an impact. We've been developing sensors, for example, for assessing the response to people after COVID vaccination. And so I think there's a lot of potential for design proteins in sensors. Basically, any area where a naturally evolved protein will not be an optimal solution. So in the case of vaccines, we've been designing these self-assembling nanoparticles that present the antigen in very high valency and give much stronger responses. In the case of therapeutics, we can design proteins which are much smaller and cheaper to manufacture than antibodies. Other areas, improved catalysts has, I think will have a huge impact on the world. They're still challenging. I'd say computational protein design is still not at the level of directed evolution in terms of creating really high activity enzymes, but I think we're getting closer. Nanomaterials, I think there's a lot of very exciting applications of protein design outside the medical realm, and things like light harvesting, making very strong materials. Biomineralization in nature, we have materials like tooth and bone and shells, seashells that were made out of proteins that nucleate the deposition of inorganic minerals, and mastering that process, I think, will have big impact. So I'm afraid I'm not really following your maxim about focus, because I think there's a lot of areas where I think protein design will have a very big impact, and so those are at least some of them.